Okay, let's do some problem solving using triangular numbers. The first one is going to be a bit of a puzzle, and it's a theory that we're going to go ahead and test. So it says Deontay said if I multiply a triangular number, apologize, there's a typo there. If I multiply a triangular number by 9 and then add 1, it will give me another triangular number. Show that Deontay is correct. So let's go ahead and start with an easy one. I know that 3 is a triangular number. I'm going to multiply that by 9 and I get 27. And then he says to go ahead and add 1, and so I get 28. Is 28 a triangular number? Yep, we just proved it in a previous problem. So that one checks out. Let's try the next one. So 6 is a triangular number. That's T3. So times 9 gives me 54. Add 1, and that gives me 55. Well, 55 we saw on the previous page is actually T10. So I know that that is a triangular number, and it all checks out. Go ahead and see if you can try out some with different numbers and make sure that this actually continues on with even bigger numbers. But so far we've been able to prove his hypothesis correct. Okay, let's take a look at the next page. The next page we have a situation where we have 6 people in a room. Everybody shakes hands with each other, but only once. Work out how many handshakes there were in total. Now, this is an easier problem than it seems. We're going to go ahead and map out each of the 6 people. So the first person is the one who shakes everyone's hand. Of course, they can't shake their own hand. So they shake the hands of 5 people, all 6 of them minus themselves. So we have 5 handshakes. The second person doesn't get to do 5 handshakes because the first person has already shaken hands with them. So number 1 is out. So 2 will be shaking hands with 3, 4, 5, and 6. So there's only 4 handshakes there. My third person. Guess what happens here? They've already shaken hands with person 1 and 2. They're not going to shake hands with themselves, and they only have person 4, 5, and 6 to go. So they're going to do 3 handshakes. Do you see the pattern? We're decreasing by 1 each time, just like our equilateral triangle of dots decreases by 1 each time that we go up that triangle. So our fourth person has 2 handshakes. Our fifth person has 1 handshake. And our sixth person has 0. Well, why is that? That 6th person has already shaken hands with person 1, person 2, person 3, person 4, and person 5. So they have no handshakes together. So let's go ahead and add all of this up. If I take 5 plus 4 plus 3 plus 2 plus 1, I end up with my total number of handshakes. So 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, and then add 1, I have 15. So there were 15 handshakes total. Now hang on a second. When we had T5, which is the number of my first number of handshakes, I believe I also had 15. So 6 people gives us a T5 situation. Okay? If I wanted to document this, I could say that the first person has 5 handshakes to give. The next person has 4 handshakes to give. The next person has 3, then 2, then 1. That would actually make my triangular graphic of T5. All right, let's take a look at 3. 3 is a little bit odd. We knew how many people were in the room the first time, and we were able to count down. This time, we don't know how many people are in the room, but we do know that everybody shakes hands with each other once. In total, there's 28 handshakes. How many people are in the room? Well, We know that 28 is a number that we've seen before, and we really, quite frankly, know what that number is. But let's go ahead and go through the process. I'm going to start with person 1. Person 1 has 0 handshakes. And the reason why they have 0 handshakes is because they are the only person and they're not going to shake hands with themselves. A second person comes in. When that person comes in, 1 and 2 shake hands with each other. So there's 1 handshake there. A third person comes in. That third person is going to shake hands with number 1 and number 2. So there's 2 more handshakes added. Now, I'm going to keep a rolling tally. This is 1. This is 3. I'm up to 3 already. A fourth person comes into the room and they shake hands with 3, 2, and 1. So there's 3 handshakes. That brings my total to 6. My fifth person enters the room and they are going to shake hands with 4, 3, 2, and 1. So that's 4 handshakes. So my tally so far is a 10. Then my sixth person is going to enter the room and they are going to shake hands with 5 people. That's going to increase my tally to 15. The seventh person enters the room. They shake hands with 6 people. That brings my tally to 21. My eighth person enters the room and they are going to shake hands with 7 people. That brings my total tally to 28. So even though 28 is a T7 number, there are 8 people in that room if we have a total of 28 handshakes. All right, so let's go ahead and there's a monitoring progress. Unfortunately, when I did this in my head, I already had 8 people here. Let's change that to 9. If we have 9 people in the room, what would that look like? I'll give you a moment to go ahead and go through that. Pause the video if you can, and then go ahead and start it once you're done. Okay, with 9 people, I'm looking at 8 handshakes, plus 7, plus 6, plus 5, plus 4, plus 3, plus 2, plus 1. So in this case, I have a total of 36 handshakes.